What we're going to be doing is we're going to be solving systems of equations by graphing again. What we talked about last time was the answer one solution. That's when we had two lines that we made a graph for, and they intersected at one point. And we labeled that as our XY ordered pair. We're going to look at two other answers that we can get. One is no solution. No solution is when we have two different lines, and those two lines have the same slope, so the first slope is equal to the second slope. These are parallel lines. They have different y-intercepts, so they never cross, and that would be no solution. And the last one is infinite amount of solutions. That's when it's the exact same line twice. So they both have the same slope and they have the same y-intercept. So we're going to look at a few of those examples. So for the first one, what we're going to do is we're going to do the same thing that we did last time. We're going to graph each of the equations. And so for our first one, our y-intercept is 0 because we're not adding or subtracting anything. Our slope, we have a negative x, so that would be negative 1 would be our slope. So that means we go down 1 to the right one. I'm going to go down 1 to the right one again to make sure my line is straight. For the second one, my y-intercept is 3, so I plot a point at 3. My slope is 2, so I'm going to go up 2 to the right 1, or I'm going to go down 2 to the left 1. And I see that it crosses right here. So this is just like what we did last time, where we have our one solution, negative 1, 1. Now for the next one, what we're going to do is we're going to plot our y-intercept, which is negative 1. And then our slope is 2. So we're going to go up 2 to the right 1. And I'm going to go up 2 to the right 1 again. And then I have my line. Now for the second one, what we're going to do is we're going to subtract the 4x on each side. And I have negative 2y equals negative 4x plus 2. I divide it by negative 2. And I have y equals 2x minus 1. So I have negative 1, I have up 2 over 1, and if you notice, both of those lines are identical. So this one right here would be infinite amount of solutions. And then for the third one, if we're looking at this right here, once again, what we're going to do is we're going to start with our first equation. Our y-intercept is 2, so we plot a point at 2. Our slope is negative 2/3, so we go down 2 to the right 3. Or we could go up 2 to the left 3. We draw our line. For the second equation, I'm going to subtract the 2x. So I have 3y equals negative 2x plus 9. I divide it by 3. And I have y equals negative 2/3 x plus 3. So my y-intercept is 3. My slope is negative 2/3. So I go down 2 to the right 3. And what we see are two parallel lines that don't cross. So this right here would be no solution. Take some time, see if you can do those next three, see what you get. Okay. Looking at letter D, for the first one, it looks like it's y equals, but it's really x equals. So what we have to do is we're going to subtract the 4, and then that gives us 2y is equal to x minus 4. I'm going to divide it by 2. And then y equals 1/2 x minus 2. So my y-intercept is negative 2. My slope is 1/2. So I go up 1 over 2, up 1 over 2. And then I'm going to draw my line. For the second one, my y-intercept is negative 4. I go up 1 over 2, up 1 over 2. And what I see is that two parallel lines, they don't cross. So my answer is no solution. For the next one, my y-intercept is 3, so I go up to 3. My slope is 1, up 1 to the right 1, or down 1 to the left 1. My second equation, y-intercept is 3. I go down 1 to the right 1, or up 1 to the left 1. And I see right here that it crosses once, and that would be the ordered pair 0, 3. Now for our last one, my y-intercept is 3, so I go up to 3. I go down 3 to the right 1, down 3 to the right 1, and I draw my line. For the next one, I'm going to subtract the 3x on both sides, and I get y equals negative 3x plus 3. My y-intercept is 3. I go down 3 to the right 1, and I see that it's the exact same line. So that would be infinite amount of solutions.